Hello, my friend. I'm Lina from Safina Development Organization. Today, I'll be taking you through what a computer network is and how networking works, step by step, in simple language, and with stories you'll remember. No heavy jargon, no complicated terms, just clear ideas and real understanding. Let's begin. Once there was a powerful computer, fast and capable, but completely alone. It could run programs, calculate numbers, and store files, but it couldn't share anything. No messages, no internet, no connection. Then one day it connected to another computer, then another. Suddenly they could share files, printers, and information. That connection, when devices are linked so they can share, is called a network. Here is the clean definition. A computer network is a group of two or more devices connected through a communication medium to share data and resources. Devices include computers, phones, printers, and servers. Connections can be wired or wireless. Sharing can be files, services, or internet access. You can think of a network as communication between digital devices. Now, networks come in different sizes, just like social circles. A small local circle is called a LAN, local area network, like a home, office, or school lab. It is fast and privately managed. A city-sized network is a MAN, metropolitan area network, connecting many LANs across a city or campus. A very large network across countries is a WAN, wide area network, and the internet is the biggest example. Your personal device bubble, like your phone connected to earbuds or a smartwatch, is a PAN, personal area network. Small, medium, wide, and personal, that's how networks are grouped. Now let's meet the devices that help networks function. First, the switch. Think of a switch like a smart building manager. It knows exactly which device is connected to which port. When data arrives, it checks its table and sends the data only to the correct device. Not to everyone, only the right destination. That makes communication efficient and quiet. A switch connects devices inside the same network and uses MAC addresses to forward data. Now the router. A router is like a post office between cities. You give it a destination address, and it forwards the data toward the next best network on the path. It doesn't carry the data all the way itself. It passes it along router to router until it reaches the destination network. A router connects different networks and uses IP addresses to decide where data should go next. Here is the clean difference. A switch works inside one network using MAC addresses. A router connects different networks using IP addresses. Before switches became common, there was another device called a hub. A hub receives data and sends it out to all connected devices at once. Every device sees every message. This creates unnecessary traffic and possible data collisions. Because of that, hubs were replaced by switches in most networks. Now let's look at a few supporting devices. A modem is a translator device that helps your local network communicate with your service provider. A firewall is a security filter that checks traffic and allows safe communication while stopping unsafe traffic. An access point provides wireless network access and allows Wi-Fi devices to join a wired network. Now let's talk about addresses, because every device in a network has two important ones. The first is the MAC address. A MAC address is a permanent physical address built into the network card. It is unique for each device and used for local network delivery. It is written in hexadecimal form. You can think of MAC as the device's built-in identity on the local network. The second is the IP address. An IP address is a logical network address assigned when a device joins a network. It can change depending on where the device connects. It is used for routing between networks. MAC is used locally. IP is used across networks. IP addresses are written like this: 192.168.1.10. Some IP ranges are reserved for private networks. These are used inside homes and organizations. Memorize these three private ranges. 10.anything. 172.16 through 172.31. 192.168.anything. These are private and reused in many networks. Inside each subnet, two addresses are special. The first address is the network address. It identifies the network itself. The last address is the broadcast address. Sending data there reaches all devices in that subnet. All the addresses in between are usable for devices. To divide network and host parts, we use something called a subnet mask. A subnet mask separates the network portion and the host portion of an IP address. Example, mask 255.255.255.0 means the first three parts are network, last part is host. Now let's move to network communication models. The most famous one is the OSI model, which describes how data moves through 7 layers. Remember this sentence. Please do not throw sausage pizza away. Physical signals and cables. Data link, MAC addresses and frames. Network, IP addresses and routing. Transport, delivery control. Session, connection management. Presentation, formatting and encryption. Application, user services. When data is sent, each layer adds its own information before transmission. This process is called encapsulation. You can imagine it like wrapping a package in labeled layers. The receiver removes the layers in reverse order. Now let's meet the two main transport protocols, TCP and UDP. TCP is the careful one. It establishes a connection, confirms delivery, and keeps data in order. It is reliable but slightly slower. It is used for web pages, email, and file transfers. UDP is the fast one. It sends data without waiting for confirmation. It is faster but less strict about delivery. It is used for streaming, voice, and online games. Different needs, different methods. Now let's look at a few essential network protocols. ARP, Address Resolution Protocol, is the helper that finds a MAC address when we already know the IP address. It asks the local network and receives the matching MAC. DHCP, Dynamic Host Configuration Protocol, automatically gives devices their IP configuration when they join a network. You can remember DHCP steps with DORA. Discover, offer, request, acknowledge. DNS, Domain Name System, is like the Internet Directory. Humans remember names like example.com, but computers use IP numbers. DNS converts names into IP addresses. So you type a name, DNS returns the number, connection happens. Now a classic shared network rule, CSMA/CD. This is a listen before send method. Devices check if the line is free before transmitting. If two send at the same time, they pause and retry after a short delay. Finally, loop protection in switched networks. When multiple paths exist between switches, loops can form. Loops cause repeated traffic and instability. Spanning Tree Protocol, STP, prevents this by keeping one active path and disabling extra paths unless they are needed. That keeps the network stable and organized. And that's your complete networking foundation, explained with stories, clear terms, and practical meaning. You now understand what networks are, how devices connect, how data moves, and how addresses and protocols work together. Take it step by step, and everything connects, just like a network does. Thanks for your time.